Okay? That's the information you need to start. During the next 30 years, the debt increased by about 10.2%.
Is that a B?
Yes, for billions.
Okay.
Each year. There's some graphing tricks we ran out of time for that I'm suddenly realizing you might have found helpful.
So would you tell me about 100? Would you move the decimal?
Hold that thought. Yes, you would, but hold that thought. We're not there yet. Okay, first thing. Yes, Amanda, do you have a question about what I've just written on the board?
Yes. Yeah, because I wasn't. So is that like how much it went up?
Yes, it went up by 10.2%. So whatever the number of the debt was, it got 10% bigger.
I have a question.
Yeah?
On the ACTs, there was like a little formula and it said I equals PRT. What is that?
We're going to get to that.
Oh.
We're going to get to that. I'm trying to get you guys to think first, formula second. That may be ambitious of me. Now, okay, again, you need to be writing this down, especially if I didn't see it written down when I came around. Okay?
And then we can tell you we did it.
I
don't know why. Yeah, write it down now.
And then we can tell you we did it.
Graphing trick. Listen carefully to this. This is important. This will come up a lot. Okay? Graphing trick. If you're graphing something in a year, okay, take that year, whenever what you're graphing starts, and make it year 0.
What?
Make 1965 equal to 0 on your graph. Okay? Yeah. Yeah. This makes the math so much simpler. It also deals with the fact that really, we don't have a graphing situation that starts in 1965 and goes back to year 0 because there was no federal debt in the year 0. There was no federal government. There was no United States in year 0. So you take 1965 and make it year 0. That's your first trick.
Is there a year 0?
Pardon?
Is there a year 0 between like these years?
Yes, but it's... No, not really. It's weird. Calendars drive me nuts. It also depends on whether you're talking about what calendar you're talking about. And even within the Catholic tradition where it starts with the birth of Christ, there are multiple calendars. And it's been changed a few times.
That's disgusting.
And they really think he was born about 4 years earlier.
Yeah,
So, it's really pretty arbitrary. But so we're going to use 1965 as our personal year 0 for this point on the federal debt.
No.
Now, number 52 says write a model giving the amount D in billions of dollars of debt T years after 1965. Let's start with that one. Okay, so D, our debt level, is going to be, we're going to start with the 322.3 billion. And since I know this is in billions, I don't have to write it. I don't have to write it out with all the zeros. And this is going to get 10% bigger every year, 10.2%. Now, Nimi, this is what you started to say a minute ago, and I want you to hold off to this point. If it's going up by 10.2%, what do I actually multiply the debt by? What decimal? Okay, that's a question you asked a minute ago. Jordan? 0.102. Changing a percent to a decimal, you move the decimal place 2 units over, and you always want to have to change the percent to a decimal before
would it
you
be 32.23? If you moved one, would you move the other one?
No, you do not. You don't change it on the debt, you only change it on the percent.
So,
okay? And now you're going to multiply this number times 0.102.
How many times?
As many times as you want to, depending on how many years you're talking about.
Except we had 0 years.
Now, yeah, but except it's important that 1965 is year 0.
So your answer is going to be 0 because...
Hold that thought. Okay. This is why it's important, and this is a math trick I really should have showed you guys yesterday. We ran out of time, and this may be why your numbers are different. If I put 0 in for t, what is anything to the 0 power?
1.
1. And if I multiply 1 times this, I will just get this number back, right?
Because it's 1965 still.
Yes, so if I make 0 into 1965, and I put 0 in here, I will correctly get the debt in 1965. Pardon? I'm just deciding that 1965 is going to be the same as 0.
How do you get a 0 from
Anything, a 0 is fine as an exponent. Anything to the 0 power is 1. So then you multiply it by that. What would happen if I put 1,965 in here?
Then you time it.
I would get a huge number, probably bigger than your calculator could handle, and I would not get an accurate answer. Okay? Does that make sense? This would basically, if I put 1,965 in here, then what I would be saying is the United States government had this much debt at the time of the birth of Christ, and it has been going up for 1,965 years since. Does that sound like an accurate statement?
Yeah.
No. So we're going to use 0 for 1965 instead. Okay? Now the next part of this question is, what is the debt in 1980? If...
2. Oh. No. I swear, I thought that's a 2. It's actually a question.
It's a question mark. Yes, thank you. Okay. I'm glad there was some reason why you were saying that. Okay, now, here's the tricky part. If 1965 is 0, what's 1980?
15.
1.
Close.
16.
No, you count up by from 60
That's
to
14.
65, right?
Yeah, but 65 is 0, not 1.
Oh,
So 66 would be 1, 2, 3, 4, 5. It will be 15.
Oh, you said I was close.
You were right. Sorry, you were, that correct is close. So now, in 1980, t equals
50.
15.
Yeah.
Don't you have to make a little like chart?
Wait, how'd you get 15 again?
Yes.
1980 minus 1965.
Oh,
Between the two? It's going to be a huge number, yeah. But now what I put into my calculator is the debt in 1980, I don't put this into my calculator, is 322.3 times
102.
0.102 hatch mark 15.
Wait, I can get you the answer.
I hope you can, actually, at this point.
No.
What do you got? Artur's got a... Okay, now, this is getting into the realm of scientific notation here.
Ha!
Really? That's what you got?
I got 4.
Now,
It's
Do you
0.102, not 105.
Do you think we need
Well,
to put
is
the
this
102 to the power of 15 in
Does
parentheses?
it need to be in parentheses?
It shouldn't need to be with a fraction here.
I got 4.3337733.
What do you mean with the fraction?
What does the E mean?
That means scientific notation, and I'll get into that in one
And then
sec.
it says E negative 13.
Okay, that is what I'm getting as well.
Negative 13.
Yeah. Yeah.
What?
4.34.
Because you moved it over to the
337.
Over to the right.
The E, if you get the
Negative 13
E,
is to the left.
guys, if you get the E and then it says...
You don't even know. Okay, what did you
Well, you're very lost in
It means times 10 to
Okay,
the power
guys,
of whatever
we made a
you-
big mistake here so far. We made a big mistake that I did not even catch. Yeah. Yesterday, no, listen up. Listen up, your calculator's results are fine. Here's what we did differently. Yesterday I said that when something was going up by 5%, you didn't multiply by 0.05. What did you multiply by?
Oh, I wasn't here yesterday.
Oh, the
5 more times.
The 97.
That, yeah, the 90.97 was when you had something depreciating. When you had something going up by 5%,
You keep you multiply it by the debt itself.
you multiply it by 1.05.
Oh yeah.
Because I said to get the $100, if you had $100 in the bank and you multiply times 1.05, you want to know how much total you have, so that's going to be 105. Multiply the 100 times the 1 and the 100
And
times the
we didn't do
0.5.
that.
No, what should we be multiplying by here?
107.
1.102.
1.102.
What?
Well,
Did you just add the
1.102.
5 from the other problem to the 2?
yes.
Okay, no, it's the other problem had nothing to do with it.
Oh.
Okay, we have to multiply times 1.102. Okay, because we want the debt plus the 10%.
So we didn't even...
Okay, so the setup was the process was fine.
Now I have another number.
Yeah, well, except for that depreciation
Wait,
one when
it's
things get
always a
smaller. Yeah,
It's
I'll show you. I'll give you the formula today.
1383.516119.
Read that out to me again.
1383.52.
0.52. Bless you.
You stole
Okay.
my thunder.
Is that the
Bless you.
Bless you.
Yes. Now remember,